In today's society, in our daily life and work, we can't live without computers. We all know that. Binary programming is used in computers. In our daily life and work, we are most familiar with decimal system. Of course, in addition to these two numbers, there are other numbers. Let's start today's learning. The concept of numbers, also known as enumeration, is a method that people use a set of prescribed symbols and rules to represent numbers. Different symbols and rules lead to different representations. The usual numbering system is the place value system, which means counting according to the rules of carry. In life, the commonly used numerals mainly include binary octal, decimal hexa, decimal. The characteristics of numbers 1. The base in a number system. Only a fixed set of number symbols can be used to represent the size of numbers. The number of digital symbols used is called the base of the number. The rule is to carry over at base B, which is called the base of the B system. For example, the base of decimal system is 10. It has 10 numeral symbols, namely 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. The base of binary is 2. It has 2 numeral symbols, 0 and 1. The base of octal system is 8. It has 8 numeral symbols, namely 0, 1, 2, 3, 4, 5, 6, and 7. The base of hexadecimal is 16. It has 16 numeral symbols, namely 0, 1, 2, 3, 4, 5, 6, 7, 8. 9 ABCD EF. The weight of the second digit in the positional number system. The power of the base is called the positional weight. The power of the base changes with the position of the digit. The integer part starts from the lowest bit, followed by 0, 1, 2, 3, 4, and so on. The decimal part starts from the highest digit, followed by -1, -2, -3, and so on. For example, decimal number 1258. It can be expanded as 1 times 10 to the third power, plus 2 times 10 to the power of 2, plus 5 times 10 to the first power, plus 8 times 10 to the 0 power. Each digit multiplied by 10 to the power of 3, 10, 2, the power of 2, 10 to the power of 1, and 10 to the 0 power is the weight of the digit, where 10 is the base of decimal system. Second, number conversions. Each type of number has its special purpose. For example, binary is mainly used in computer programming. For the convenience of writing and reading, therefore various numbers often need to be converted. First, non-decimal numbers are converted to decimal numbers. The method is to expand and sum each non-decimal number according to positional weights. 1 binary numbers to decimal numbers. For example, binary 110. 1 is converted to decimal. It's 1 to 2 the third power, plus 1 to 2 the second power, plus 0 asterisk to 2 the first power, plus 1 2 to the 0 power, which is 13. Second octal to decimal. For example, octal no. 125 is converted to decimal. Equals 1 乘8 squared. Plus 28 to the first power. Plus 58 to the 0 power. It's equal to 81, converting hexadecimal numbers to decimal numbers. For example, hexadecimal number 35D is converted to decimal, equals 3 times 16 squared, plus 5 times 16 to the first power, plus 13 times 16 to the 0 power equals 861. 2 decimal numbers to other bases. Decimal no. 2. Binary number. When converting decimal numbers to binary numbers, we should use division by 2 and take the remainder until the quotient is O. The order rule can be summarized as, the first remainder is low, and the latter remainder is high, that is, the last remainder is the high bit, proceeding sequentially to the lower positions. For example, converting decimal number 227 binary number, the result is decimal number 227 is equal to binary no, 110011. Decimal number 2, octal number. Hexadecimal number. Using divide by 8 remainder method and divide by 16 remainder method to convert. The order rule can be summarized as the first remainder is placed at the least significant bit. The last remainder is the high bit. That is, the final remainder is the high bit and goes to the low bit. For example, converting decimal number 92 to octal. The result is decimal number 92 is equal to octal no. 134. 3. Binary 2 and hexadecimal number. Binary no. 2. Octal number. The method is to convert binary numbers to octal numbers based on their corresponding relationships in terms of digits, grouping them in threes to form an octal number. Starting from the right, each 3 binary digits form a group. When the last group is less than 3 bits, add zeros to the left to make up 3 bits. For example, if we convert the binary no, 11111111 into octal number, the result is binary 11111111 is equal to octal no, 16657. Second binary to hexadecimal conversion. The method is based on their corresponding relationships in terms of digits. Convert the binary number 2, hexadecimal, separately. Each 4 bits form a group to form a hexadecimal digit. Starting from the right, each 4 binary digits form a group. When the last digit is less than 4 bits, add zeros to the left to make up for bits. For example, convert the binary number 1110110. 1, 1, 1, 2, hexadecimal. The result is binary 11111111 equals hexadecimal number 1 day. 4. Octal number and hexadecimal no and dos. Binary number. It's just the reverse process of the above. Replace each octal or hexadecimal digit with the corresponding binary number, using 3 bits for octal digits and 4 bits for hexadecimal digits. After learning this lesson, I believe you have learned several common numbers, binary octodecimal, and hexadecimal. I hope you can master the conversion rules and master the conversion between different numbers.